Now we just looked at permuting a list of 5 movies, and we found that there was actually 120 different ways to permute those 5 movies. I listed a couple of them up here, but 120 is a lot. It's 5 factorial, and if you have 5 movies without replacement, that's the number of different ways you can order them. Well, here's a question. How many permutations are there of the 3 letters A, E, and T? Well, you can write them in that order, A, E, T. You could do A, T, E, and there's really no other combination that starts with an A, right? A goes with E then T, or T then E. That's it. So then you pick another letter to start with. Let's start with E. Then if you use E, you either have AT or TA. Okay, so you have those 2 combinations. So then you pick the only letter left to start with is T. So you pick the T and you go with AE or EA. And so we've used all the different combinations, right? I've started with each of the 3 letters, and within each of the 3 you only have 2 ways to order them. And so what we have here are 6 different permutations, right? The order is important. The order gives you an individual permutation. And so the number of permutations is 3 times 2 times 1, or of course 3 factorial. Actually, I'll write it out that way. It'd be 3 factorial, which is 3 times 2 times 1, or 6. Okay, there are 6 different permutations here. And that works anytime that you're just scrambling a set of numbers and you're using all of them. Okay? So permutations, when using all of the elements within the set, you get just the factorial, that number factorial. Okay? Now let's say you weren't using all the number or all of the elements of the set. For instance, if you went back to my movie example, we had The Dark Knight, we had Apollo 13, we had Rocky 4. I'll use the number 4. Rocky 4, Hunger Games, and The Matrix. Right, those were my 5 favorite movies. If you went with those 5 movies, but let's say, if I was going to binge watch those over a weekend, I wouldn't get them all in one day. I'd do some Saturday and some Sunday or something like that. So let's say I wanted to watch 3 of them on Saturday, okay? The question is, how many permutations of 3 out of the 5 could I have on that Saturday? Well, maybe Saturday I wanted to watch Rocky 4, followed by The Matrix, followed by Apollo 13, okay? That would be 1 permutation. Let's say I wanted to do the Hunger Games, followed by The Dark Knight, followed by The Matrix. Well, that would be a permutation. And so you can see how basically you're picking 3 out of the 5 and then permuting them. And there's a way to count that as well. And it's also using factorials. What you'll find is that for each of the choices that you make, you're going to be able to multiply using the fundamental counting principle again. So in the first slot, you'll have 5 options. I'm going to go through the same breakdown again, okay? The second slot, you would have 4 options. And in the third slot, you would have 3 options. All right, once you remove one, the first one, you'll have 4 left. You remove the second one, you'll have 3 left to choose from. There's going to be 2 unused movies in that first day, okay, on that Saturday, which is fine. Okay, watch those on Sunday. That's all right. So here we go. These 3 combinations. Well, that tells us that the number of permutations of 3 movies out of a set of 5 is 5 times 4 times 3, which is 20 times 3, which is 60. Okay, That's the number of permutations that you could get. You could get 60 different combinations of 3 out of those 5. So the question is, where did the other factors go? The 2 and the 1 that were also in there from the factorial, where did they go? Well, the formula then, if you were to remove, basically if you were to take 5 objects and not watch 2 of them, you're basically taking those 2 off, you're dividing them out. And so the formula for the permutations is going to be n factorial, or let's think about it this way. In this particular example, it's equivalent to 5 factorial divided by 2 factorial. The 2 are the ones being left out, you're dividing them out. And so you have the 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. If you cancel the 2's and the 1's, you get the 5 times 4 times 3, which is the 60. So you're dividing out the ones that aren't used, okay? Now how do I formalize this? Well, if you have, if you're permuting n items, no, I'm sorry. If you're permuting, what is it? R out of n. Make sure I get my variables consistent with the book here. Permute R items out of a set of n. Use n factorial over, so n is the total number in the set, right? So here I've got 5 movies, that's my n. That's a set of 5, but I'm only permuting r of them, which would be 3. Well, how do I get the 2 on the bottom? I find the difference between the 5 and the 3, right? So it's the difference between n and r. So it's n minus r factorial. Right, so in our case here, n is the 5, r is 3, so the quantity n minus r is what's equal to 2. It's the remaining leftover stuff that's not being used getting divided out. Okay. All right, so that gives us then a formula for the number of permutations. Okay. Now there's a notation that we use for this this formula. We use n permute r. So it's a big P with n, with a subscript of n and a subscript of r. The n on the left, the r on the right. The n on the left gives you the numerator, how many are in the total set. R on the right gives you how many are actually being chosen to permute. Okay. Okay, so here's another example. Actually, I'm going to put the next example in the next video while I erase all this.